nice to see you. I guess that if you're watching this video, you've probably encountered the binomial theorem for positive integer indices. However, if n is a fraction or negative, or both, we can still use the binomial formula shown. It's the binomial theorem. 1 plus x to the power of n. 1 plus nx plus nn minus 1. Divide this bit by 2 and times the square of x. Note that there always has to be a 1 in the brackets. Always. I can't repeat that often enough. There has to be a 1 in the brackets, okay? Got that? Always. We'll start with example 1, where we just have to find the first 4 terms of 1 plus 2x to the minus 2 and 1 minus 4x to the half. So for our first question, big X is 2x and n is minus 2. Substituting these into the song, we get this expression, I can't be bothered to read out, which simplifies to 1 minus 4x plus 12x squared minus 32x cubed. A couple of tips I'd like to share with you. Don't forget that we have to square the 2 in 2x squared and cube the 2 in 2x cubed. And 2 factorial, or 2 with exclamation mark, doesn't mean 2! It means 2 times 1. And similarly, 3 factorial means 3 times 2 times 1. For the second question, big X is minus 4x and n is a half. Substituting these into the song, we get another expression I won't be reading out loud, which simplifies to 1 minus 2x squared minus 4x cubed. Oh yeah, another tip, be careful when simplifying. It's not hard to make an error when cancelling down all those bits. Okay, you may recall I mentioned earlier that there has to be a 1 in the brackets, always. It's got to be a 1. So what do we do if there isn't a 1, given that there's got to be a 1? Well, we just rearrange our expression to make sure that there is a 1. And here's example 2 to show us how. Find the first 3 terms of 4 minus 3x to the power of minus 3 over 2. So, we need to get the 4 out of the brackets. If we factorise the 4 out, we get a 1 in the brackets, which of course is what we've been aiming for. But we also get minus 3/4 x instead of minus 3x. We just got to live with that. Okay? So what it means is that we're now going to apply the binomial theorem to 1 minus 3/4 x to the minus 3 over 2, which is a 1 in the brackets, yay. But we still have to consider the 4 we've removed. The 4 is also still raised to the power of minus 3 over 2, which makes it an 1/8. So whatever we get from the binomial theorem needs to be divided by 8, that's all. So we have an 1/8 outside our expansion, which I will not be reading out, and some lovely fractions in our final answer of 1/8 plus 9/64 x plus 135 over 1024 x squared. Thank you very much for watching.